Hello everyone, in this lecture we will learn about mutable and immutable objects. So mutable objects can be modified after it is created. For example, list, set, dictionary. All these are mutable objects. Whereas immutable objects cannot be modified once it is created. So after creating the object, for example here int, float, string, you create a string, you cannot modify it. You cannot assign a new value to that particular location. We'll see with the example. Let's create a new file. Mutable, immutable objects. So int, float, boolean, string, all are immutable objects. It means they cannot be modified once they are created. Let's see one example. Here it is integer. A value is 10. I'll print A equals to, and I'll print the value of A, and I'll print type. So what type this variable is having. After that I'll change the value. Now I'll add a string. This is Python. This again I'll repeat this print statement. So let's run it. You can see A is 10, class is int, then A is a string and it's a string. But integer, this value should not be modified, right? Then how it is working? So here you have to understand one thing. Usually we see this variable and see the values. So this A contains 10. I'll show one. Let's here see A equals to 10. Now it will create one memory location. That location is known as A and value is 10. Then A, we specify a new string. So what exactly happened here? First this A, here it is, you can see contains 10. Now it will not go to the same location and modify this string or update this part. What it will do, it will create a new memory location. This value is assigned here. So this value is stored here, and this location is known as A. So what happened to this location? So problem is here we are reading from left to right. We always focus more on this variable. So we say A contains this value, right? A contains this value. A is assigned with new value. Instead of that, we must read in a reverse way, from right to left. Then it will be easy. So I'll show you the same thing with the help of that. Let me just, okay. Now when you say A equals to 10, let's read from right to left. So there is a value 10, okay, that is stored in this location, okay, and this location can be accessed with the help of A. So A can point to this location, right? Now when we say a equals to Python new string, so what we will do, again here this Python, it's a string, okay, and it is stored in this location, and this location can be accessed with the help of a. Now a will not point to this memory location, but a will point to this memory location. So what happened to this location? It will be there, okay, it will be there. You can access this, we'll see that later. So it's like a tagging. We just take the tag from this location, and this location can be accessed first with the help of a. Now because value is changed and we cannot modify the existing thing, we have seen it is immutable, we cannot modify it. So in this case it will create a new memory location with the new value, and that location now is called a. So this is a concept of tagging. You can take this tag and you can assign a new tag to that element. So this way it works. But then in programming language, in here, how to confirm this? You can see from here it's very difficult to understand how it works. But there is one more function, built-in function, that is known as ID. You can understand it's like this returns an address, or it is called identity. Okay, so it will return a number in memory, so or you can call it address. So from there we can understand. Let's print it. Now first a is pointing to this, or you can say 10 memory location is pointed by a, and then we will print the address of this 10. Then one more string is created. This string is pointed by a, and this is the reference. So both should be different. Now you can see here, you can see this ID identity and this one, both are different. So it means it is not this, when you assign a new value to this variable, it is not modifying the existing, which is 10. 10 is still there. It will create a new memory location. What we can do to we'll create a new variable with this value 10, which is already assigned. Now here we have seen this 10, right? 10 will be there. So when we create a new variable, because 10 is already there, what it will do? It will just take this memory location and known as b. So b will start pointing to this location. It will not create a new memory location. So b is assigned a value, again 10. I'll print same thing here, this time for b. Okay, so the first and the third, both should be same. The ID should be same. Let's run it, and you can see here for a value is 10, ID is this one, and for b value is 10, ID is exactly same of ID a. So it proves that when we create a new variable with the same value, it is not creating a new location, it's pointing to this location only. So the only thing is this variable, this pointer is changed. Because it is immutable, you cannot modify it. But this way it works behind the scene. So Python will not create a new location. When we create a new value, so in that case it will just create a new memory location and give that value a name. One more thing here. Let's I don't need this one. Let's only print the ID of 10. So it is possible to print the reference or identity of a value rather than variable. Now 10, you can see the first, third, fourth ID should be same. And you can see the first ID is this one 740 at the end, here also and here also. So very useful concept. Whenever you want to print identity, the reference address, you can call anything. You can use ID to make sure it is same object or different object. So all these immutable objects work like that. When you create a new, when you give a new value, it will not go and modify the existing location. It will create a new location with that value, and that value is known as that variable. But the previous one will be there, which we can always access. When we assign a new variable, it will take that value only, that location only. Let's comment. So list is mutable. We can modify it. Let's print this list, and I'll print the type. List means it contains different elements. Collection, which is mutable, and I'll print the ID. So ID of this list. Now let's modify this. So how to modify? I'll go to index value 1 and change this value. So one more thing I'll do, I'll append with the help of this function. I'll append one more element here. Let's say last element. Now again I print this. So let's run this and see here. This identity is same. I modified that. I am able to modify the existing element. Previously it was 3 in this location. Now it is this new value, and a new element is added here, and ID is not changed. You can see here it's same. So this is very important concept to understand. With the help of ID, we can always find out the reference point or this identity or address. Remember, all objects, everything is object in Python, and all objects are divided into two categories, either mutable or immutable.